Welcome to this lesson on working with ratios and using equivalent ratios to solve problems. So we're going to start off with this first problem and we're going to read the actual question. We want to know how many of each type of vehicle were registered in the county in the month of August. All right, so I'm going to actually underline here each type. That's important that I want to know each type. So this actually tells me that I'm going to have multiple answers. Right now I don't know how many. I have to look at the information in the problem and find out. So let's go through and read. We have the county superintendent of highways who's interested in the numbers of different types of vehicles that regularly travel within his county. Yeah, that's not really important to us. That's just kind of setting up the problem. So I'm just going to go ahead and cross it out. In the month of August, so that's good because we know that it's August, a total of 192 registrations were purchased for passenger cars and pickup trucks, so cars and trucks, at the local DMV. The DMV reported that in the month of August, so again we're with August, for every 5 passenger cars, there were 7 pickup trucks. Well, now I know, so they gave me this ratio of 5 to 7, and I know that we have a total of 192. So I know 5 and 7 cannot give me a total of 192. So I know that this has to be a simplified ratio and then that the actual information here would be the 192 total. Okay, so now we're looking at this going, okay, well, 192 and 5 to 7, how are we going to connect these two pieces? This is where the different parts of information that you can find from a given ratio really help you out and come into play. Because even though they might not tell you all these different pieces, you can use them to help you solve problems. So let's pull all this apart. We know that there are 5 cars, and we know that there are 7 trucks. Previously, we had discussed the fact that you can take both of these and you can find a total. So we know there are 12 total vehicles from our simplified ratio. And I see total here and total here, so that might be helpful in the future. And then there's one more piece. If I take 7 and 5 and subtract them, I get 2. And I know that there are 2 more trucks than there are cars. This is information that can also be used. So there's a couple of ways to look at this. I can write a new ratio. I can use my tape diagram. There are lots of different things. So here I know that this is cars, and I'm going to show you 2 ways to kind of look at this. And this is trucks. I know that total right now this is 12 because each is worth 1. So currently the value is 1 for each box. I know that this total though has to somehow give me 192 vehicles. So what I can do is I can take that total and divide it by the number of boxes because I also know that the value of each box has to be equal. So if I divide this, so I'm going to actually do 192 divided by 12. 12 goes into 19 once. Minus 12 is 72. 12 goes into 72 6 times. And I get 0. So I know each box is worth 16. So here I have 16, 16, 16, 16. Then I can do, so now I know that each box represents 16 cars. So I can take 16 and multiply it by 5. And I know that I get 80 cars. So that's one piece. So that's one type. And then I know that each of these is 16. So now I can do 16 times 7, and I know 7 times 6 gives me 42, carry the 4, 7 plus 4 is 11, so I get 112. So I know that there's 112 trucks. So here are my 2 answers for my number of each type. Now, this is just by using a tape diagram and recognizing that the total 12 boxes would work with the 192 total of the actual ratio. Another way that I can do this is I can say, okay, well, I'm going to make a new ratio that uses 12 and one that uses, or that can kind of get us to 192. So here is what I can do. I can sit here and say, okay, well, for every, let's say, 5 cars, there are 12 total cars. And then I can draw another tape diagram if it helps. Right now, this is kind of helping us out a little bit. And this is going to be a little rough because I know that my boxes aren't going to work out perfectly. So I have 5, 1, 2, 3, 4, 5, and then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, of course. Let's make this a smidge longer. 11, 12. All right, well, I know right now that all of these are worth 1, and that this is the total, and that this is cars. So I know that this somehow has to equal 192. So again, I end up doing 192 divided by 12, which I already know is 16. So I know each box is worth 16. So I end up doing 16 times 5, which ends up getting me 80. Then I know that there are 80 cars, so I can take my 192 total, subtract the 80 cars, and I get 112, so that would have to be the number of trucks. Again, there's so many different ways to look at this and that we can do this. Now, there's also just the applied math of it. So yes, you have to be able to give me the visual of what's going on, so using your tape diagram. But then there's also, let's say we did the 5 to 12. And then I want to know how I can get x to 192. Well, as we had mentioned before, we have to figure out, and notice the math is all going to be the same, how do I go from 12 to 192? So I end up doing 192 divided by 12, which we said is 16. So then I know that to go from here to here, I have to multiply by 16. So to go from here to here, I have to multiply by 16. So every one car in these 5 cars is actually representing 16 cars that are actually on the road. So these 5 cars within this ratio, each one of them represents 16 cars that are actually on the road. Okay, again, this is confusing. This is why we're going to take some time to go over these and work with this. But this is really what it comes down to, is being able to find these pieces of information and to use them with what was given to you. Okay, we're going to try one more problem here. If you feel comfortable and you want to try it on your own, absolutely go ahead and do so. And come back and check your answer. So we want to know, how many did each boy sell? So each boy tells me I'm going to have multiple answers. I have Sammy and David, so that tells me that there's 2 people. So 2 answers. And they're selling water bottles to raise money for new football uniforms. Sammy sold 5 water bottles for every 3 water bottles that David sold. So together they sold 160 water bottles. So we know that this is a total, and this is an actual total. This isn't part of this ratio. So we have this ratio of Sammy to David, which is 5 to 3. And again, this is simplified. Okay, and then we have the actual total of 160. So here what we can do is we can say, all right, well, we have 5 to 3. So 1, 2, 3, 1, 2, 3, 4, 5. So now here I know that all of these have to somehow give me 160. Well, let's look at our pieces again. Our pieces of information that we can find from that ratio. We know that 5 is how many Sammy sold. 3 is how many David sold. 8 is the total they sold based on the simplified. And 2 is how many more Sammy sold than David. So more Sammy sold than David. Right? So we're working with the total. So we're not working with the more. We're not working with just with David. We're not working with Sammy. We're working with this 8 total. So I know these 8 total boxes somehow have to represent 160. So I have 160 and I'm going to divide it by 8 and I get 20. So each one water bottle in the ratio actually represents 20 water bottles that they've sold in real life or in total. So I know I do 3 times 20 and that tells me that David sold 60 and I can do 20 times 5 and that's 100 and Sammy sold 100 water bottles. Okay, again, you can set this up. You have to be able to show these different visuals of what's going on, and I really like the idea of when you circle this and say all of it has to equal 160. We worked with this previously and it really helped students out, so I encourage you to do this and we'll be looking for it, especially if you're struggling. And let's say that we were working with the 2 more, well then these right here would be the 2 more. So remember, you got to find what each thing represents. Right? So there's a lot of different ways to do this. We have to be able to do the visual with the tape diagram, and then let's also look at the ratio. So I know that I have 5 to 3 in this simplified ratio and 160 with this total. So I'm actually going to take this ratio and say, okay, well, 5 to 8 has to equal something to 160. I know here I'm multiplying by 20, so I know this ratio is 20 times the size of this ratio. So I have to do whatever I do to my total, I have to do to the number of bottles that Sammy sold. So I know X would give me 100. And then I know that my total is 160, so I'd have to subtract that 100 to find that, so the 100 was Sammy, that David sold the 60. Okay. Again, there's all these different pieces going on, and I know it seems crazy and confusing. We're going to take time. We're going to go over these things. The visuals really start to help students out as we go through, so that way we can get to this point where it's starting to make sense, really understanding that every one of these water bottles here, so every one represents 20 actual. And we were able to find that based on our total ratio and finding the equivalent ratios. Okay? So you do have 2 problems that you're going to be doing on your own. Now in this case, there may be 1 or 2 that talk to you about more, so you have to look at where the more comes from, and this is where I'm letting you kind of try it on your own to see what you come up with. Please do not look at it and say, oh, it's hard, I'm not going to do it. Please try it, give it a start, so that way we can see where your thinking is at and build from there. As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.